In this video, we'll take a look at how you use the sine and cosine laws to find angles and sides. And more specifically, I want to address here not just how you use it, but when can you use the sine law to find an angle or a side, and the same for the cosine law. So let's say in this diagram on the left here, we're asked to find side E. So if I'm finding side E, I'd have to write out my sine law with a side E in it, so I need a little E here. Remember, angles are, this is a normal convention, angles are normally uppercase letters, and the sides opposite are the lowercase version. So angle E, side little e, angle F, side little f, etc. And so here's my sine law, and whenever you have an equation, if you have just one equation, and this applies not just to trigonometry, but you have to know everything else in the equation to find the one unknown. If you have two unknowns, then you see you need a second equation, but that's not generally what you're doing in trigonometry. Notice in this, in order to find side E, I need to know angle E, okay, the angle opposite the one I'm finding, and I need to know both angle D and side D. In order to use the sine law, you always have to know, and I call it an angle-side pair. I know angle D and I know side D. And so I know actually three of the four things here, so I can find the fourth thing, the unknown E. Now, there's also a sine F over F here, but, and I'm just mentioning this briefly, I don't know angle F and I don't know side F, so I really don't need that. Okay, so that's why I didn't bother to write it first, so we'll get rid of that. Now, it could be that you, in the beginning, you don't know that angle D, but instead you know angle F. And it appears right now that I don't know an angle side pair. I don't know angle D, but I do know side D. Well, if you do know two of the three angles in a triangle, then what you can do is subtract those from 180, because in a plane triangle, all three angles add to 180. And so we're back to knowing angle D again. It is 61 degrees. So I do have now my angle side pair, and I have this angle E, so I can find side E. So if we fill in all the values here, angle E is 38, angle D is 61, and side D is 23. And so a lot of people call this cross multiplying. E times the sine of 61 is equal to the product of 23 and the sine of 38. And so I want to isolate the E, the little e, so I would divide out the sine of 61. And so here's the calculation to find E. It's 23 sine 38 over the sine of 61. And so here's the intermediate step. You might not need to write this and be able to do it right in your calculator, but the sine of 38 is about 0.6157, and the sine of 61 is about 0.8746. So we multiply these, divide by this decimal, and side E works out to be about 16.2. Let's take a look at the finding an angle now. The instructions for this might be to find angle B, for example. And if in a triangle you know, again, you have to know an angle side pair. So that's the same as if you're finding a side. You still need an angle side pair. So know angle A and side A. If I'm finding angle B, I have to know the side opposite it in order to be able to use the sine law. And here's my sine law again. So if I'm finding angle B, I need a sine B over the side B, and it would equal sine A over A. I know angle A and side A. If it was angle C and side C, I knew instead that I would have a capital C and a little c here. So notice in this again, I do know three of the four things. I know angle A, side A, and side B, so I can find angle B. So again, you need that angle side pair and the thing opposite you're finding. I'm finding an angle in this case, so I need to know the opposite side. So we fill in the values. Side B is a 13.4, angle A is the 41, and side A is this 9.2 here. And so we cross multiply very similar to this step here. 9.2 times the sine of B would equal 13.4 times the sine of 41. And I want to find B, so I would next try to isolate the sine of B. So this 9.2 is multiplied by it, so we would divide out the 9.2. And so this is what sine B equals. It's 13.4 sine 41 over 9.2. And so in your calculator, evaluate the sine of 42. It's 0.6561. And then we multiply it by 13.4 and then divide out the 9.2. So the sine of B is approximately 0.9556. I normally keep 4 decimal places. Don't round too quickly or your end answer might be off by a degree or two. So to find angle B, we take the inverse sine of this, which is about 73 degrees. So to recap, using the sine law, you need to know an angle side pair, and then if you're finding an angle, you have to know the opposite side. Again, if we're finding a side, you still need an angle-side pair, and in order to find a side, you need to know the opposite angle. So it's always an angle-side pair using the sine law, and to find anything, you need to know the opposite thing. Let's turn over to take a look at the cosine law here. So let's say the instructions here would be to find side f. Now, the way the cosine law is written, if I'm finding side f, then it would be the f squared I'd have alone on one side here. And in order to use the cosine law to find a side, you need to know the other two sides, and these d and e here, of course, the same as the two here. And you need to know the angle opposite the side you're finding. So to find a side in using the cos law, you need to know the other two sides and the angle between them. That's the scenario under which you can use the cos law to find a side. You need to know the other two sides and the angle across from what you're finding, or the ones between the two sides you know. Now, if this actually will work for right triangles. If the angle here were 90 degrees, this is just a what if, just briefly. If this were 90 degrees, then this would actually be a right angle triangle. And the cos of 90 is 0. So if you actually had a right triangle, this would be 0. So this whole term would be 0. And it would actually become Pythagoras' theorem. You might have noticed that the first part of the cosine looks like Pythagoras' theorem. The Pythagoras' theorem is actually a special case of the cosine law, because if you have a right triangle and you're finding that hypotenuse, that longest side, then the angle is 90, and then this becomes 0, and you actually get Pythagoras' theorem. Okay, it's not 0 here, so we're just going to plug in the values and find what side f is, but I thought I'd mention that. So side D is 18, side E is the 21, and again 18 and 21 here, and the angle F is 118. So the next thing I do is square these, multiply this. So 18 squared is 324, 21 squared is 441. And then now this is all multiplied together. So 2 times 18 times 21 is 756. Notice I still have the minus sign here. The cos of 118 is negative 0.4695. And I specifically chose an example here that the angle is bigger than 90 degrees. This is called an oblique triangle. And that's because if the angle is bigger than 90, this cosine value will always be negative. And so what we actually have here is negative 756 times negative 0.4695. And so remember, multiplying two negatives works out to be a positive. So this actually works out to be 354.942. These two numbers add together give you the 765. So these two add to 765, and this will be a plus 354.942 because of the fact that you're multiplying two negatives to give a plus here. So we add these together, we get 1119.942, and then to find side f, we take the square root of that. So side f works out to be about 33.5. So that's how you find a side using the cosine law. You need to know the other two sides and the angle between them. Now let's talk about finding angles with the cosine law. In order to find any angle using the cosine law, what you need to know is all the sides. And notice in this triangle I don't know any angles, but I do know all of the sides. There's 7, 9, and 13. And so if I tried to find an angle using the sine law, so here's a little bit about why you can't use the sine law here. Let's say I tried to find angle, I want to find angle C. So I would write sine C over C because I'm trying to find angle C, so I need that part. So I'll write sine A over A. Well, the problem is I do know the A and C sides, so I can put 9 in place of A and 7 in place of C. But the problem is that I'm trying to find angle C, but I also don't know angle A. So to use the sine law to find any angle, you have to know another angle. Remember, you need that angle side pair. So that's why the sine law will not work here, because you don't have the right kind of information. To find anything using the sine law, you need a full angle side pair, and you do not have that here. So we'll get rid of those. But you can use the cosine law. So to find angle C, I would write out the cosine law for side C. It's kind of like if I was finding side C first. And the reason you write it out that way is because that's the cosine law, one of the three that can be written for this triangle, that has the cos of angle C in it. So I'm finding angle C, so I need a cos of C here. So I wouldn't write out the one with the cos of A or angle B because I'm finding angle C. So notice that in this formula, you know side C is 7, side A is 9, side B is 13. So you have all this other information. So we're back to, we have an equation, we know everything in it except what we're trying to find, so we can find that angle C. So we fill in all the values. Side C is 7, again side A is 9, side B is 13, of course 9 and 13 same as these two here, times the cosine of angle C. So the next thing I would do is evaluate all these squares and products. 7 squared is 49, 9 squared is 81, and 13 squared is 169. Then I would multiply the 2, 9, and 13 to get 234 here. And now I'm trying to find C, so I would want to isolate the term that has the cos C in it. So I'm going to rearrange this way. I'm going to take that term to the left, or some people would say, well, add 234 cos C to both sides, and I'll bring the 49 to the right. So I'll get all my numbers on the right, the term that has C, the cos of C, on the left. So the 234 cos C would be on the left, the 81 plus 169, and of course be minus 49 on the right. Next thing I want to do is just go 81 plus 169 minus 49, that's 201. And then I'm trying to find what angle C is, so I would divide out the 234. So the cos of C equals 201 over 234. And so I would divide that in my calculator to get approximately 0.8590. And I want to find what angle C is, so I would take the inverse cosine of this, which works out to be about 31 degrees. So to recap, to use the cosine law to find a side, you need to know the other two sides, the angle between them. To use the cosine law to find an angle, that's when you have to know all of the sides, and then you can use it to find any angle. In fact, I could have just as easily found angle B or angle A here. I would just write another version of the cosine law. Okay, one more page here. Let's say in this triangle, you might recognize this is the second one from the first page, and on that page, remember we found angle B. So let's say you were instead asked to find side C or angle C, one of those two, instead of you weren't asked originally to find angle B. Well, I cannot find side C using the cosine law because although I do know the other two sides, I don't know the angle opposite this, if you remember from the last page. Okay, so I can't use the cosine law to find C. And I can't use the sine law to find this side because although I know an angle side pair, again, in order to find that using the sine law, I'd have to know the angle opposite it. So I cannot find that angle directly, and then sort of the same thing would be true for angle C here. I can't find it using the sine law because I don't know the thing opposite it, and I don't know an angle side pair. So what you could do though is you could find angle B even though you're not asked to find it. You kind of need to do that first, and then we can find side C or angle C. And so this is exactly what I wrote in the first page. So we could do that, and then to find the angle B is 73. And so now that I have angle B is 73, I know an angle side pair. So I could use the sine law and find that side. I could also, of course, find angle C fairly easily now by just subtracting the two of those from 180. So I know angle C is 66. And the only thing left is side C. Now, as soon as you get to the point in a triangle where you know lots of sides and angles, see, we only have one unknown. We know all the angles here and two of the three sides. And you get more options. And now we actually can use the cosine law. We could also use the sine law. In fact, we could use two different versions of the sine law because we know so many things in this triangle now. So we could use the cosine law to find this because we do know the other two sides and the angle between them. So that's what it would look like. And of course, we could use the sine law as well. We could write the sine of 66 over C is equal to the sine of 41 over 9.2. Or instead of this, we actually could use the sine of 73 over 13.4. So either of these could be here, being equal to the sine of 66 over C. Now, I'm not going to go through all the details like I did in the previous pages, but this all evaluates to 163.915 approximately. So we take the square root of that, we get C to be about 12.8. I'll demonstrate the same thing over here. Of course, we should get the same amount for side C. Cross multiplying, we would go 9.2 times the sine of 66 and then divide out the sine of 41 for side C. And for if we use this one with this instead, it would be 13.4 times the sine of 66 divided by the sine of 73. And in both cases, those of course both work out to 12.8. So you have lots of options there to find side C. So that's a little bit about how you can use the sine law and cos law to find angles and sides and under what scenarios they work.